conversion of a number. The next one is conversion of a number in one base to a number in another base. All right, so how do you convert a number in one base to a number in another base? So let's look at how it is done. This is the combination of converting a number in one base to a number in base 10, and then converting the number in base 10 to a number in the required base using the method discussed earlier. All right, so if you have this kind of problem, you have to convert the number to base 10, then from base 10 to the required base. Example, convert 1345 in base 5, 134 in base 5 to base 10, but to base 2. So if you are converting 134 in base 5 to base 2, so you have to convert this 134 in base 5 to base 10 first. After converting to base 10, then from base 10 you convert to base 2. Okay, so first convert to base 10. So to convert to base 10, this is expansion method. Of course, 134 in base 5 is going to be 1 times 5 plus 3 times 5 plus 4 times 5, and then raised to power of 0, okay, and then 1, and then 2. Of course, if you don't know how this is done, you can still go back and watch the video or watch the part that I taught converting from not a base to base 10, converting from a base to base 10. So I've done that part already, so you can go and look up for it and watch it. And after you have gotten this, of course, 1 times 2 raised to power 2 give us 25, plus 3 times 5 raised to power 1 is 5, plus 4 times 0, 5 raised to power 0 is 1. Of course, any number raised to power 0 is 1. Then apart from that, we have 1 times 25 is 25, plus 3 times 5 is 15, plus 4 times 1 is 4. 25 plus 15 plus 4 will give us 44 over 10. Now we are over 44 in base 10. Now we have convert this particular number to base 10. Remember, but we are supposed to convert to base 2. So by the time we convert to base 10, from base 10 now we can convert to base 2. So they then convert the base 10 to base 2. Of course, if you are converting from base 10 to any other base, use this LCM method, then get your remainder. How many times 2 into 44 is 22, remainder 0. 2 into 22 is 11, remainder 0. 2 into 11 is 5, remainder 1. 2 into 5 is 2, remainder 1. Then 2 into 2 will give us 1, remainder 0. Then 2 into 1 is 0, remainder 1. So you have to stop at 0. So you copy your answer upward, and of course the answer is going to be 101100. So therefore, what you are going to have is 134 in base 5. You convert to base 10, it will be 44 in base 10. And then if you convert to the base 2, which is the answer to the question they ask us, is going to be 101100 in base 2. Of course, you copy upward. Okay, so just for look at this example. If 2, 3, 4, 5 in base 6 is equals to x in base 9, find x, find the value of x. If you have this kind of problem, how do you find the value of x? To find the value of x, you discover that you need to convert this to base 10. Remember, there is no way you can treat this number and this number together except they are in the same base. So we have to convert this base 6 to base 9. By the time we convert to base 9 here, we can now say x in base 9 is equals to that value that this number is going to give us in base 9. All right, so we want to find x. Okay, but before then, let's convert this number to base 10. Then from base 10 to base 9. Okay, so converting to base 10 is going to be an expansion method. All right, so 3 times the base, which is 6, and then plus 2 times 6 which is the base. 4 times the base, which is 4 times 6 plus 5, the last digit, this last digit, times 6 again. Then we start putting our value on the base, which is 6, 0 from 0, 0, 1 power to power 2, then to power 3. Then this is equals to 3 times 6 raised to power 3 is 216 plus 2 times 6 raised to power 2 is 36 plus 4, 6 raised to power 1 is 4 plus 5, then 6 raised to power 0 is 1. So 3 times 216 is 648 plus 2 times 36 is 72 plus 4 times 6 is 24 plus 5 times 1 is 5. So 648 plus 72 plus 24 plus 5 is going to give us 749 in base 10. But that's not where we are going. So we have to convert from this base 10 to base 9 because our x is given in base 9. So if that is the case, then we are going to have then convert the number in base 10 to a number in base 9. So of course, from base 10 to any other base, use the LCM method. I've said that before. 9 into 749 will give us 83 remainder 2. And then 9 into 83 will give us 9 remainder 2. 9 into 9 will give us 1 remainder 0. Then 9 into 0 into 1 it cannot. So 0 remainder this one, you bring the 1 down. So we copy our answer upward. Answer is going to be 1022. So 2, 3, 4, 5 in base 6 is the same thing as 749 in base 10. It's also the same thing as 1022 in base 9. 1022 in base 9. So which is equals to x in base 9. So therefore, this implies that the value of x in base 9 is 1022 in base 9. So this is how we convert. Okay, this is how these conversions are done. When you are doing your conversion, conversion of a number in one base to a number in another base. This is how it is done. So if there are areas you are not getting clear, you can forward back the video and then listen to it again. So the next one is conversion of decimal number, base to base 10, all right. So if you have a decimal, how do you convert? We have done with a normal whole number. So let's look at decimal now. Okay, so if you are doing decimal, example 1, convert 101.011 in base 2 to base 10. So solution, this is how it is done. Now this solution, what we have here is going to be 101.011 in base 2 is going to be equals to normal expansion method. I will show you where there is a little difference. So 1 times 2, which is the base, 1 times this 2 is what we have here, plus 0 times 2 is what we have here, plus 1 times 2 is what we have here. Then the next one now is 0. The next one is 0, but let's forget about this point. I'll tell you what to do with this point. So 2 times 0 times 2 is what we have here, 0 times 2. Then the next one is 1 times the base times this 2 is what we have here. Then the last one, 1 times 2 again, is what we have here. Okay, this is what we have here. Then how do you put the power? How do you put the power? You need to locate this last digit. This one, you have to locate it in this sector. This is where it is. Then the base of it, the base is 2. So from that base, you start with 0. To your left hand side, the next one is 1. The next one is 2. Then come to it again after the point. Immediately after the point, the first digit is 0. So locate that 0 again. Then after 0, the next thing is minus 1 on the number line. So the base, which is 2 here, will carry minus 1 to your right now, minus 2, and then minus 3. That is how to put it. So by the time you are done like that, you start solving this, expanding it. This is equals to 1 times 2 raised to power 2 is 4 plus 0 times 2 raised to power 1 is 2 plus 1 times 2 raised to power 0 is 1 plus 0 times 2 raised to power minus 1. Of course, 2 raised to power minus 1 means 1 over 2. That is what it means. 2 raised to power minus 1 means 1 over 2. The minus there means over. Okay, plus 1 times 2 raised to power minus 2. 2 raised to power minus 2, what it means is that it means 1 over 2 raised to power 2, and 2 raised to power 2 is 4. So minus means 1 over. Okay, 1 over. All right. Then 2 raised to power 2 is 4 plus this one done. Then 2 raised to power minus 3. 2 raised to power minus 3, like what we did here. See, minus means 1 over, 1 over. Then 2 raised to power 2 is 4. Then this minus means 1 over. Then 2 raised to power 3 is 8. Look at the 8 here. So this is how it is done. Then from here, we have 1 times 4 is 4. 0 times 2 is 0. Anything multiplied by 0 is 0. Then plus 1 times 1 is 1. Then 0 times 1 over 2 is 0. Plus 1 times 1 over 4 is 1 over 4. Plus 1 times 1 over 8 is 1 over 8. Now, here 4 plus 0 plus 1 is this 5. Then plus. If you add this particular fraction together, you discover that the LCM between 4 and 8 is 8. The LCM of 4 and 8 is 8. So if the LCM of 4 and 8 is 8, therefore 8 divided by 4, 8 divided by 4 is 2. 2 times 1 on top there, look at it, will give us this 2. That's what we have 2 here. Then 8, the same thing, 8, then this plus here. Then 8 divided by 8 is 1. Then 1, that 1 times this 1 on top, 1 times 1 is still 1. So that's why we have this 1 here. Equals to 5, this 5 down, plus 2 plus 1 is 3, all over 8. This is the same thing as, if you add this to this, it's going to give us 5 whole number, 3 over 8. Then by the time you divide this, or if you want to take it to decimal, 8 times 5 plus 3, by the time you divide it, take it to decimal, you discover that you have 5.375 in base 10. So you can leave your answer in fraction or in this mixed number or in front of a decimal number. Okay, so example 2, very fast. We have express 241.23 in base 8 in base 10. We want to take it to base 10. Of course, it's going to be an expansion method. So the same process follows. 2 times 8, which is the base. Then the next one is 4 times 8. This is the 4 here times this 8. The next one, 1 times 8. We got it from 1 times 8. Then dot. This dot, we don't need to put the dot anywhere here. All right, the dot will change the power only. So 2 times 8 plus 2 times 8. Then 3 times 8 plus 3 times 8. Then we have to locate this dot. From this dot to the right, you start with minus 1 to the right. Then from this dot to the left, you start with 0 to the left. So the last digit here before the dot is 1. Look at the 1 here. So the power, the base of it is, the base is 8. So the base multiplied by the last digit, start from 0 to the left, 1, and then 2. Then after the point, the first number is 2. So this is the 2 multiplied by the base. So now that it multiplied by this base, what you are going to do now is, after 0, of course, it's going, after this 0, of course, the next thing is minus 1, and then minus 2. Then 2 down times 8 raised to power 2, 64 plus 4 times 8 raised to power 1 is 8 plus 1 down times 8 raised to power 0 is 1 plus 2 down times 8 raised to power minus 1. Remember, this minus means 1 over. So this is the 1 over 8 raised to power 1 is 8. Then plus 3 down times 8 raised to power minus 2. This minus means 1 over. Then 8 raised to power 2 is 64. All right, so 2 times 64 is 28. Then plus 4 times 8 is 32. Plus 1 times 1 will give us 1. Then 2 times 8. 2 times 1 over 8 rather. 2 times 1 over 8. Then so it's going to be 2 times 1 all over 8. That's why we have 2 over 8 here. So 2 times 1 is 2, so it's over 8. So this is what we have. Plus 3, this 3 times 1 is 3 over 64. Then from there, we are going to have 128 plus 32 plus 1 is 161 plus the LCM between 8 and 64 is 64. Look at it. Write 64, put your division line on top of it. 64 divided by 8, what it gives you, you are going to multiply it by, by 2. 64 divided by 8 is what? The answer it gives you, which is 8 times 2 is 64, is 16. So we write 16. Then also, the next one is 64. 64 divided by 64 is 1. So that 1 times 3 is 3. So that's why we have 3 here. So plus 3. This plus is what we bring there. So 161 plus 16 plus 3 will give us 19 all over 64. If you add this to this, it's going to be 161 whole number, 19 over 64. If you convert it to fraction, press your calculator, it's going to give you 161 dot 0.297 in base 10. Okay, so that is 161 dot 19 divided by 6 will give you 297. So that is how we get it in base 10. Okay, so we have another example here, very fast. Convert 0124 in base 5. 0124 in base 5 to base 10. The same procedure, we have 0 times 5, then plus 124 in base 5. We are still going to take, after this dot, we continue with 1 times 5, then 2 times 5, 2 times 5 here, then 4 times 5 plus 4 times 5 here. Of course, this is where the point is. So to the left, we start with this 0 times 5. To the left, we start with 0. So there's no any other number again. So it's just power is 0. Then plus this, after the point, we start with 1. So this is the 1. So the power of it is start with minus 1, minus 2, and minus 3. So here, 0 times 5 raised to power 0, any number raised to power 0 is 1, plus 1 then times 5 raised to power minus 1. Minus means 1 all over. This minus here, raised to power minus here is 1 all over. 1 all over. 5 raised to power 1 is 5. Plus this 2 down times 5 raised to power 5 raised to power 2 minus 2. You discover that this minus, it means 1 all over. Then 5 raised to power 2 is 25. That is 5 times 5. Then plus 4 down times 5 raised to power minus 3. 1 minus means 1 all over. So 5 raised to power 3 is 125. Now listen, 5 raised to power 3 is 5. What it means is 5 times 5 times 5. That's 5 in 3, please. 5 times 5 times 5. It's not 5 times 3. Many students will write 5 times 3 and that will be 15, which is wrong. It's 5 times 5 times 5. Okay, which is 125. So 0 times 1 is 0. You need to multiply by 0 is 0 plus 1 plus 1 times 1 all over 5 is 1 all over 5 plus 2 times 1 all over 25. 2 times 1 is 2 all over 25, so 2 all over 25. 4 times 1 is 4, so all over 125. So 4 all over 125. Then 0 plus the LCM between 525 and 125 is 125. That is the LCM. So write the LCM, put your division line on top. This is this division line on top. Then let me show you how we get 25, 10, and 4. So it's going to be 125 divided by 5. By the time you divide it by 5, is to give you 25. If you have your calculator, you can be following me. It will give you 25. 25 times this one, 25 times 1 is still 25. That's why we have this 25 here. Plus, the same thing goes for the second one. 125. 125 divided by 25. 125 divided by this 25 is going to give us 5. So 5 times 2 is 10. Look at the 10 here. So, okay, so that is how this 10 is gotten. Okay, so the 125 divided by 125 is 1. And 1 times 4 will give us 4. That's how we get this 4. So we have 0, is 0 down, plus 25 plus 10 plus 4 give us 39 all over 125. Of course, 0 plus all of this is still the same thing. 0 plus 3, 9, 39 over 125. See the thing now is 39 over 125. So if you divide 39 all over 125 using your calculator, you are going to get 0.312 and base 10.